Nilsson, Volvo Construction Equipment, R&D department called Future Solutions. What we have here is a bit of a teaser, a tech demo, if you like, of a simulation, a rigid body simulation with a bunch of different solvers that is running in Unreal Engine for visualization purposes. The same kind of game engine that is used in the Visual Studio here. Difference is that all the physics simulation, the chaos physics engine, have been thrown out and replaced by the physics engine running here. It's running in real-time performance, or it is real-time performant, and has solvers for tires, hydraulics, rigid bodies, material that we can see here. This is highly useful for what we see here, prototypes, testing them out before we build them, but it's of course also possible to use it for conventional machinery, operator training, and so on. And the hope is to run development on this platform using the computational power, perhaps the screens for visualization purposes. And that's about it. Over to you.
Thank you, Alba. My name is Brian Ruvold. I'm a postdoctoral researcher here at VTH. I'm coordinator of this lab. So the other parts that I want to point out about the operational lab that we have here is the engine that we're running in order to depict this part of our Volvo example is simply that, as an example of one of our many collaborations. But Volvo has long been a very key collaborator that we have. The other part that I want to point out from what we're watching here is that this engine is not just an engine built in isolation. We test and run known machines that we have that are over in the corner of this operating space right now, wheel loaders and existing machinery. We test them, we understand how they work in the real world, and then we bring them into this digital environment, and then we tweak and tune the physics settings so that the operational output and physics representations of that machine are matching to the virtual prototype that we have in there. So that means that we have, to some degree, validated our virtual environment so that when we bring in new concepts like this Zoox machine here, we can be far more confident that the outputs we get from running this virtual simulation are representative of what we will see in the real world. And that helps us because the idea here is that you don't want to be stuck only building prototypes with physical operations and physical machines only, where you can do one or two maybe per year. But in this instance, we could theoretically run hundreds or thousands of these prototype machines, and utilizing other multi-model simulations, run total cost of ownership models, and really test our ideas out here as fast as possible and as many times as possible. So, thank you. That's pretty much it.